Hi, today we'll use machine learning to predict the winners of NBA games. First, we'll read in box scores from NBA games for the last 7 seasons. Second, we'll use feature selection to pick the stats that will give the most accuracy when we're making predictions. Third, we'll train a machine learning model and use it to predict games in our historical data. We'll end with a look at how you can actually predict future games using the same technique. All right, let's dive in and start coding. We'll be using Jupyter Lab for this tutorial, and we'll be coding in Python. You can use any place that has Jupyter notebooks, including Google Colab. So I'm first going to create a new notebook. Then I'm going to rename this new notebook. I'm going to call it Predict Live. You can call yours Predict, probably a bit easier. Then I'm going to go ahead and import a library called pandas. I'm going to import it as PD just to make it easier to type out. If you don't have it installed, you can run pip install pandas in Jupyter Notebook to actually install it. This won't run as Python code. This little percentage will actually run what's called a Jupyter magic that calls pip to install the package. Once we've installed pandas, we can read in our data. So if you went through the last video, you'll have the data file. If you didn't, there is a link to download the data file in the description of this video. We can use the pandas read CSV function to read the file in. The file is called nbagames.csv. Make sure it's in the same folder as your code. And we're going to specify that the index column is 0, which means that when we save the CSV file, the first column is our pandas index. So let's take a look at our data frame. On the left, these values in bold are the index values, and pandas assigns an index to each row, and that's what lets us call the row by its index. All right, so we can see we have 17,000 rows and 150 columns. So each row in this data is one NBA game. And the columns are a bunch of different stats about that game. There's also some metadata as well. So if we look towards the end, we can see there's metadata about the season. So this is the season the game was played, the date the game was played, and who won. So we'll dive more into the columns later, but most of the columns are really just stats about how the team performed in the game or how their opponent performed in the game. All right. So once we have this data frame, we can go ahead and just sort it. So we're going to call the sort values method in pandas, which will sort a data frame by a single column. So if we scroll up here, you can see that the date column is not in order. So there's a date here, 2021, and it comes before some of these dates, like 2016. So we want to just make sure the data frame is sorted in order of date. It's going to make some of our processing later on easier. So we'll go ahead and sort it. Once it's sorted though, you'll notice these index values get out of order. And it's important to make sure that however we want the data frame to be sorted by date, the index also matches. It'll make some processing easier later. So we're going to call the reset index method on the data frame, which will basically change the index to another set of values. And we're going to say drop equals true. So if we don't pass drop equals true, the old index will be added to a column, but we don't want that. We want a new index, but without actually making the old index a column. We don't need to keep it around. So we'll run that. And now our data frame is indexed from 0 to 17,771. And it's in the same order as our date. When you're working with time series data, like this data, usually want to make sure your index is either the date itself or follows the same order as the dates. All right. Now, there's a few extraneous columns that we're just going to delete. You may notice these two columns are the same. So the first column is minutes played, so how many minutes the team played in the game, which is a good indicator of whether the team played overtime or not. But these two columns are identical, so we can actually remove mp.1. There's a couple other columns that are like that. So we're going to use the del command to actually remove them. So we're going to remove mp.1. We're going to remove mpop.1, which is a similar minutes played column, but for the opponent team, hence the underscore op. We're also going to remove a column called index op. If you watched the last video, we added this column because we merged some data together when we were doing our cleaning and processing. And this is just an extra column that we don't need. All right. So we can take a look at our data frame now. And it looks mostly the same, but we're down to 147 columns. We've removed a few of them. The next thing we want to do is add our target in. So if we look at our data frame and we scroll all the way to the right, we see this one column at the right. And this column tells us if the team won the game or not. So false means the team lost, true means the team won. What we want to do, though, is predict how the team did in the next game. So we need to set up a target that basically tells us how the team did in their next game. And in order to do that, we need to first write a function. It's going to be called add target, and it's going to take in, let's say, team. So this is a data frame that only has box scores for one team. And then what we're going to say is team target is going to equal team1.shift -1. And it's easier to actually show you what the shift is doing than tell you. So I'm going to write a little bit more code and then I'll show you what it actually did. But at a really high level, this is going to pull the one column from the next game and pull it back one row. All right. Now to use this function, we're going to call dataframe.groupByTeam. So we're going to split our data frame up. This data frame with 17,000 rows, we're going to split it up into one data frame per team. So each team will get their own little data frame. We're going to pass in group keys equals false. If you don't pass this, then pandas will add extra levels to the index, which we don't want. And to each of these individual groups, we're going to apply this function add target. The reason we do this is we need to split our data frame up by team before we pull the next row back and use it as our target, because we want how the team did in the next game. So by splitting up by team, we're making sure we get the specific team's next game and not some random other team's next game. All right, so let's go ahead and run this. Group is not defined. I typed group here instead of team, but that should say team. All right. And to see how this is working, I'm going to take a look at just the part of the data frame for my favorite team, which sadly is the Washington Wizards. They never actually do very well. Some season we'll win 50 games. But what this is going to do is it's going to take only the rows from our data frame where the team code is WAS. And if we look at our team column, it's indicating which team played in the game with that 3-letter abbreviation. So NOP is New Orleans Pelicans, CLE is Cleveland, and so on. So WAS is the code for the Washington Wizards. So let's go ahead and run this. And this will show us the 580 rows we have for the Wizards, where each row is a game the Wizards played. We can scroll to the right. We can see that this is still in order of date because we sorted by date. And what we can see is that the target is the next value of the one column. So for example, this third row, the Wizards actually lost the game. And you can see the target in the second row is false because we pulled this value back one row. So this indicates how the target indicates if the team won or lost their next game, whereas the one column indicates if they won or lost their current game. So we're going to use all the other columns to predict our target. All right, we need to do a little bit of processing on our target. And the first thing we're going to do is we're going to find all of the null values in the target. All right. So what this is going to do is it's going to take our target column And then it's going to use the pandas is null function, which will return true if a value is null, false if it isn't. And it's going to pass in the target column. And this is basically going to give us all of the null values in the target column. And you'll see at the very end here, there is a null value. Why is that? It's because there is no next game. This is the last game the Wizards played in the 2022 season. And as I'm making this video, the 2023 season hasn't started yet. So there's no next game where we can pull back the value of if the Wizards won or lost the game. So this shows is missing. So we're just going to find all of those missing rows, and we're going to replace them with the number 2. All right. Then we're also going to transform these true and false values in the target column as well. So we're going to turn a false into 0 and a true into 1. So to do that, we're going to, again, go to our target column, and we're going to say this equals the data frame target, use the as type method, which converts a pandas column from one data type to another. In this case, we're converting it from a Boolean data type into an integer data type. And we're going to say errors equals ignore. So if there's an error converting the Boolean into an integer, don't worry about it. We can take a look at our data frame again. We can see that target now has 3 values, 0, 1, and 2. 0 means a loss, 1 means a win, 2 means we actually don't have data for the next game because this was the last game we have data for that team. Okay, this is going to be what we try to predict. Let's take a quick look at our columns just to make sure they're balanced. So if we look at the 1 column, we can see that it's perfectly balanced. We have the same amount of false, the team lost, and true, the team won, which makes sense. NBA games always have a winner and a loser. There are no ties, no matter how many overtimes they have to go into. I think the record is 7, which is crazy. It's a lot of overtime. We can take a look at our target as well. Our target is not perfectly balanced because of these 2 values, because sometimes a team does not have a next game, so it was coded as a 2 instead of a win or a loss. Okay. Then what we can do is we need to remove a few additional columns. So some of our columns have null values in them, and null values don't work well in a machine learning model. So for most machine learning models to work, you need to remove any of your columns that have null values or fill in the null values. So to see what we should do, let's just check how many columns have null values. And we can use the pandas is null function, pass in the data frame. So this will tell you if each entry in the data frame is null or not. So we'll take a look at nulls. We can see it's the exact same shape as our data frame, but each cell now has false if it is not null and true if it is null. So what we can do is run the sum function, and this will find the count of the trues in each column. So the count of the null values in each column. So we can take a look at nulls again. All right, so most columns have no missing values. This dot dot in the middle is because pandas truncated the output of nulls. There's actually 148 columns, so we're not seeing a lot of them. So to simplify this, let's only take a look at the columns where the count of the nulls is greater than 0. So there's just a few columns there, and we'll assign that back to the nulls variable. And what we can actually do, because there's only a few columns and they appear to be entirely null values, is we'll just delete these columns. All right, so we're going to create a list of valid columns. These are columns that don't have any null values in them. So we'll select the columns from our data frame. So this is just it's easy to think of it as a list. It's not quite a list. It's a pandas index, but it's basically works a lot like a list of all of the columns in the data frame. And then we're going to index this list and say we want to only select the columns that are not in nulls.index. So this tilde is a negation operator for pandas series. In this case, we're checking to see if the data frame column is actually in the nulls index. So let me just display the nulls again. So we're basically checking to see if the name of the data frame column is one of these, and we're only keeping it if it isn't. So we're getting rid of all the null columns, and then we're going to assign that to this list valid columns. So let's take a look at valid columns. You can see the length is 142. So we've removed some of the extra columns here that we didn't need because they had null values. Then we're going to take our data frame and we're only going to select the valid columns. And then we're going to copy it, because sometimes if you assign a data frame back, slices of a data frame back to itself, you can get a setting with copy warning down the line. .copy helps us avoid that by just creating a new data frame, not a slice of an existing data frame. All right, so we end up with same number of rows, but 142 columns. All right, enough data cleaning. We can now go to the fun part, machine learning. And to help us do the machine learning, we're going to use a library called scikit-learn. If you don't have it installed, you can do pip install scikit-learn, and that will install it. We're going to import a few classes from scikit-learn to help us. Before we do machine learning, for most machine learning algorithms, you don't want to pass in a high number of columns. It can cause issues for a few reasons. One, the columns can be correlated, which certain algorithms don't handle very well. Two, some of the columns can cause overfitting or other issues with the model. So before we train our machine learning model, we're actually going to use something called a feature selector to select a smaller set of columns for us to train a model with. So to use a feature selector, you need to first import it. So from sklearn.model_selection, we're going to import time series split. This is a class that we need to use with our feature selector. This is going to split our data up properly when we're doing feature selection. You may be familiar with cross-validation. Cross-validation is a strategy for creating predictions across your whole data set without making predictions on the same data your algorithm was trained with. So what we don't want to do is train an algorithm on all of this data and then make predictions on the same data, because that's kind of like cheating. Your algorithm has seen all of the data that it's making predictions on. In the real world, when you're making predictions, you're predicting the future and you don't know what's going to happen, right? So cross-validation is a way to say, we're going to split the data up, we're going to train the algorithm on one piece of the data and then make a prediction on a different piece of the data. Our data is time series data, right? Each row is associated with a specific date and time. So we want to be careful when we split our data up to make sure we only use past data to predict the future, not the other way around. So the time series split ensures that we will, for example, use data from 2015 to predict what happens in 2022, but not the other way around, because that would be unrealistic and give us a model that does not work properly in the real world. All right, then we're going to go ahead and import our feature selector. This is going to be called sequential feature selector. And then we're going to import a machine learning model called a ridge classifier. So this uses ridge regression to actually do classification and classify if the team is going to lose or win their next game. So we'll go ahead and initialize our ridge classifier. There's a parameter called alpha that you pass into a ridge classifier. I'm not going to talk too much about it, but I do have a video that explains this parameter and how it works if you want to watch. Then we're going to set up our time series split. Then we're finally going to set up our sequential feature selector. Sequential feature selector. It's always a tough one to type out. And into this sequential feature selector, we're going to pass our machine learning model. The selector is actually going to train the model using different sets of features. And a feature is just a column. So we have 142 features. it's going to train the model using different sets of features. So it'll pick one feature, train the model, see how well the model does, pick another feature, see how well the model does. And that's how it's going to pick the best features for us. We're going to pass in n features to select, which just tells the model how many features we want to pick. So we're starting with 142. So we'll pick about 20%. We'll end up with 30 features. We're going to say direction equals forward. This is a sequential feature selector, so you can pick forward or backward. What forward does is it will start with 0 features, pick the feature that improves accuracy for the model the most, then keep doing that until we get to 30. We're going to pass in our time series split, which we'll use for cross-validation. All right, so let's go ahead and just define those. So we're not running anything yet. We're just initializing all of these when we run the cell. Next, we need to actually run the sequential feature selection. Before we do that, we actually need to scale some of the columns in our data. Ridge regression works best if you actually scale the data by subtracting the mean and dividing by standard deviation. We're going to do a little bit more aggressive scaling, and we'll actually scale all of our columns so they fall between the values 0 and 1. And if we want to do ratios or anything down the line, that makes it easier than if we scale the mean to be 0. All right, so to do that, we're first going to just define a few columns. These are metadata columns or other columns that we don't want to scale, right? It doesn't make sense to scale our season or our date, or if the team won or the target. We also can't scale our team code or team op. If you'll remember, these are the 3-letter codes for each team. So these are the columns we're not going to scale. And then we're going to define a list called selected columns. And this is going to be the columns that we do scale. So it'll be df.columns. So it'll select all of the columns except the columns that are in this removed columns list. So this is similar to what we did before. We're again using the negation operator. We're saying pick all of the columns in our data frame except these columns. So that's selected columns. Now we're ready to actually do our scaling. And this is another import from scikit-learn. So we're going to import our min-max scalar. Then we'll define the scalar. So this is just a class that we need to define. It doesn't take any arguments. Or it does take arguments, but we don't need to pass any in. Then we're going to scale our selected columns. So we're going to pick just the selected columns from our data frame, and we're going to run scalar.fitTransform. So this is a method on the scalar, and we're going to pass in data frame selected columns. So we can go ahead and take a look at our data frame. Some of these columns like field goal percentage and 3-point percentage were already between 0 and 1. But for all of the other columns like field goals or minutes played, they've been rescaled to fall between 0 and 1. So the minimum value is now 0, the maximum value is now 1. And this just makes ridge regression perform a little bit better. All right. And you can see that the columns we didn't want to scale have not been scaled. Good for us. Okay, now we're ready to go ahead and fit our sequential feature selector. So we call the fit method on the selector. We pass in our selected columns, and we also pass in the target. So we're going to pick the best features, the 30 best features for predicting this target. So let's go ahead and run that. All right, and once it's done running, we'll see this nice representation of the selector. This is a nice thing they added in newer versions of scikit-learn. Pretty cool. Our next step is to actually get the list of our predictor columns out of the sequential feature selector. And to do that, we're going to take our selected columns list that we passed into the selector, and we're going to call the sfs.getSupport method. And what this is going to do is if the feature selector has picked that column and it thinks it's a column we should use in our model, this will be true. If not, it'll be false. So indexing the selected columns by this will just give us the list of columns we should be using. So we can take a look at predictors, and we end up with these columns. So this is a mix of, these are just stats from the game. So overall, how the team shot 3-pointers. These are individual stats. So the player on the team who got the highest 3-point percentage is 3-point percentage max. This is opponent team stats, and this is opponent player stats. So we've picked a mix of predictors. All right, we're almost ready to use these predictors to actually predict who's going to win the next game. But we need to write a little function called backtest. So this function is actually going to do the work of making the predictions for us. And I'll explain these parameters in a second. All right, so I mentioned earlier that we have time series data, and we can't just split the data up with typical cross-validation. We have to make sure to use historical data to predict future data. So what this backtest function will do is it'll split our data up by season and use the past seasons to predict the future seasons. For example, the first season we have data for is 2016. So we set our start parameter to 2, which means that we need at least 2 seasons of data before we start making predictions. So the first season we're actually going to make predictions for is 2018. And for 2018, we're going to use 2016 and 2017 data to make predictions for 2018. Then we're going to use 2016, 2017, and 2018 to make predictions for 2019, and so on. This list all predictions is going to be a list of data frames, where each data frame is the predictions for a single season. Then we'll go ahead and create a list of seasons. So this will be all of the seasons that exist in our data. So let me go ahead and show you what this is going to look like. I'll just change this to df. So these are all of our seasons that we have data for. Then we're just going to loop through these seasons. So we're going to start with our start parameter, which by default is 2, but you can override when you call the function. We'll go up to the length of our seasons, and we will progress with this step parameter. So if you wanted to instead jump ahead, make predictions for 2 seasons at a time, you could set this to 2. Then we'll just pull out the season number, and then we'll split up our training and our test data. So our training data is the data we use to train our machine learning algorithm. And this is going to be all of the data that comes before the current season. And then our test data is going to be the data we use to generate predictions. And this is going to be the current season. So the first time through this loop, I is going to be 2 because we're starting at 2. So we're going to take 0, 1, 2. We're going to take the 2018 season as our first season. Then the training set is going to be all the data from 2016 and 2017. And our test set is going to be 2018. And then each time we go through the loop, we'll just keep going up 1, take all the previous data as the training data, and make predictions for the current season. All right. Then what we'll do is we'll fit our model by calling the .fit method. And what this will do is it'll take our training data, so all of our predictors. So these predictors are what we're using, giving the model to actually make its judgments about who will win the game. And then the target. So the target is the actual thing we're trying to predict. So we also need to feed that into the model so it can actually calibrate and figure out which predictors correlate to the target. Then we're going to generate our predictions using model.predict test predictors. So this is going to make predictions on the test set. As I mentioned before, we don't make predictions on the same data we train on because that'll just make the model look really good, but it's very unrealistic. It doesn't match the real world. So this will help us understand how good our model is on our historical data. All right. So by default, model.predict will return a NumPy array. NumPy arrays are not fun to work with. So we're actually going to go ahead and convert this to a pandas series. And we're going to keep the index the same as our test set index. This will just make it easier to combine our actuals and our predictions. Then we'll create a data frame called combined, and we'll use the pandas concatenate function, which puts two series or data frames together. And what we'll do is we'll put together the actual values, so the target, these are the correct values, and the predictions. And we're going to pass in axis equals 1, which means treat this and this as separate columns, and the result should have 2 columns. If you did axis 0, the result would have 1 column, and it would combine them all and assume they're all different rows in the data set. All right. Then we'll just rename our columns to make them a little bit easier to understand. So we'll call this actual and prediction. And then to this list all predictions, we're going to append the combined data frame. Then at the end, all predictions is going to be a list of 5 different data frames, 1 for each of these seasons. And at the end of the function, we're just going to combine all of those data frames into 1. If you don't pass in the axis parameter, it'll default to axis 0. So all of these data frames have the same columns, but we want to combine them as separate rows. So it'll make one long data frame. All right. So we wrote the function. Now we can finally do the machine learning. So we are going to call our backtest function. We're going to pass in our data, our ridge classifier model, and our predictors. We can take a look at our predictions. We can see our actual and our prediction. All right, so there's cases where we're correct, right? Our prediction matches the actual. There's cases where we're incorrect, where the actual and the prediction are different. So what we want to do is actually create one metric that can tell us how accurate our model was without having to look through all of these. So what we're going to do is we're going to say from sklearn.metrics import accuracy score. And we will call this accuracy score function. And we'll pass in our actual values, actual, and we'll pass in our prediction. And this will just compare the two, and it'll give us the percentage of the time when our prediction was correct. So let's take a look. We can see our prediction was correct 54.7% of the time, which is not bad. It means that we can predict correctly who's going to win an NBA game 54.7% of the time. Now these twos, if we wanted to make this a little bit more accurate, we could take these out. So we could say predictions equals predictions, target, predictions, target does not equal 2. So if you wanted a little bit more accuracy, you could do that. It's not strictly necessary. Sorry, not target. Predictions actual does not equal 2. It doesn't change accuracy too much because it's only a few rows. It's only about 30 rows in our data set where the target is 2. So it doesn't change accuracy too much, but if you really want to be careful, you can definitely do that. Okay, so we've come a long way. We've done feature selection. We've trained our initial model. We can now make our model a little bit better. And the first thing we want to do to help us do that is to set a baseline for what good accuracy is. So you may know if you watch the NBA that a team that's at home is much more likely to win than a team that's away. So we can check to see how often the team is at home and actually use that as our baseline accuracy. So we're going to go ahead and group our accuracy by the home column using group by. I'll actually remove this list here. We don't need that. And then we're going to apply a function to just figure out what percentage of the time the team wins based on whether they're at home or not. So first I'm going to select all the rows where the team won. I'm going to figure out the count of that. And then I'm going to divide by just the total number of rows. So what this is going to do is it's going to split the data frame into 2 groups. In one group, all of the teams will be at home, and the other group, they'll be away. And then it's going to find the winning percentage for each of those groups. So we can see when a team is at home, their winning percentage is 57%. So just by predicting that the team at home will win, we can actually get pretty good accuracy. So we want to beat this 57% benchmark for our accuracy. All right. So to do that, we need to do a few things. One is adding a few extra columns that are actually based on rolling averages. So let's go back up and look at our data frame. Actually, we'll take a look at it down here. So we can see our data frame here. And right now, when we're making predictions, we're only looking at the current game to predict the next game. But something could be weird in the current game, right? The team could have played really well or really badly, and it could have nothing to do with how the team usually plays. They just could have had a random game where they just played differently than they usually do. So, what we can do is take an average of how the team performed in their last 10 games and use that to actually give our algorithm information that it can use to predict how the team will perform in their next game. So, we're first going to create a data frame called data frame rolling. And we're going to take a few different columns and add it into this data frame. So we're going to take our selected columns from before. This doesn't include all of the columns we removed. And then we're going to add in a few extra columns to help us compute our rolling averages. So this is just a subset of our columns in our main data frame. You can see we've removed 3 columns. Then we'll write a quick function that can find the team averages. So just like we did earlier, we're going to split up our data frame by team and then find the performance for that team in the last 10 games. And we're going to use the rolling method to do that. So this is a pandas method that groups rows and the previous 10 rows. In this case, we passed in 10. So for every row in our data frame, it's going to find the previous 10 rows, which are the previous 10 games the team played. And then we're going to write .mean to take the mean of all of the columns in those 10 rows. So basically what this is going to do is for every game, we're going to find the average performance of the team in their previous 10 games. And then we'll go ahead and return rolling. And to make this all work, we need another group by. df_rolling dot group by. This time we're going to group by team and season. And the reason why we want to group by team is we want to make sure that the average performance in previous games is specific to the team, right? It's not useful if we take some games from the Warriors, some games from the Wizards, and average them all together. That's not going to tell our algorithm anything. We want to look at the performance of a given team in its previous 10 games. So that's why we group by team. Now, we also group by season. And the reason we're doing that is teams change a lot from season to season, right? In the off season, there might be trades, players might leave in free agency, you might get a new coach. And what we want to do is make sure that we only use rolling averages from that season to actually compute a history of how the team performed. So we're grouping by season as well. And then we're going to pass in group keys equals false. If we don't pass this in, pandas will add another level to our index, which we don't want. Makes it a little hard to work with. And then we'll apply our find team averages function. All right, so let's go ahead and take a look at our rolling data frame. All right, so for many of the rows, it's found the previous 10 rows, previous 10 games in that season for that team, and computed the averages. For some rows, you see there's a lot of missing values. And the reason for this is at the beginning of a season, a team has not played 10 prior games. So what this does is it results in these missing values because pandas is saying, well, I tried to find the previous 10 rows, but I couldn't because there weren't 10 previous rows. So it just returned missing values. So we're actually just going to remove these missing values, and our algorithm just won't be able to make predictions for the first 10 games in the season. If you want to change this, you can just change the previous number of games that it looks at. So you could change it to 2, and in this case, it'll just take the previous 2 games, or previous 1 game actually, the current game and the previous game. So you can change this around if you want to make predictions early in the season, but for now, we're going to leave it at 10. All right, so that's our data frame rolling. Now we need to combine our rolling columns with our regular columns that we have in our data frame. So we're first going to go ahead and rename these rolling columns. You'll notice the names are the same as the names in our original data frame. So if we just merge them right now, they'll overlap. We want to rename them first. So we're just going to take the column name and add _10 to the end. So this is just going to basically add _10 to each column name, which indicates that it's the rolling average for the previous 10 games. Then we're going to rename the columns by assigning to the .columns property. Then we're going to concatenate using the pandas concat function, our original data frame and the data frame with our rolling averages. And we're going to say axis equals 1. And if you'll remember from earlier, axis equals 1 combines two data frames using the columns to combine. So it'll make a wide data frame. If you do axis equals 0, it makes a tall data frame by putting the rows together. We can take a look at our data frame now. We can see we're up to 280 columns because we've added all of these columns with the _10. Now we need to deal with these missing values if we want to use this in most machine learning algorithms. So we're just going to say df equals df.dropNA, and that's going to drop any rows that have missing values in them. So this will drop the first 10 games in the season. And we can take a look at our data frame now. We can see we're down to 15,882 rows, and we still have 280 columns, and we have no missing values now. All right. The next thing we're going to do to improve accuracy is give the algorithm a little bit of information about the next game, information that we know in advance in the real world. So in the real world, we know if the next game will be at home or away, and we know who the opponent will be. So we're going to give the algorithm that information so it can make better judgments. So we're going to write a function called shift column. It's going to take in a team data frame and a column name. And then it's going to create a next column. So it's basically similar to what we did before when we created the target, but slightly different syntax because I want to use this function multiple times. So this is going to take essentially the value from the next game and shift it back one row. And then we'll write a function to add a column based on the shift column function. This is going to take in our main data frame, and it's going to take in the column name that we want to aggregate based on. So this is going to, again, group by team, and we're going to pass in group keys equals false. And then it's going to apply a function. And that function is going to be that shift column function we just wrote. All right. And then what we can do is actually use this function to give our algorithm knowledge about the next game. So this column is going to be called home next, and it's going to indicate if the team will be home or away in its next game. All right, so let's trace what's happening here. So we're going to create a new column called home next, and the output of this add column function is going to be assigned to that new column. So we're passing in our data frame and a column home. Then when we call this function, it's going to run this group by. It's going to group by team because we want to just get the next game home value for the specific team. Then it's going to apply this function, shift _ call. We're going to pass in the team data frame, so data just for one team, and we're going to pass in the column name. And then what the shift call is going to do is take that column and shift it one position. Just like we did with the target, it's going to take the next row's value and shift it back to the current row, which is going to get the next column, the next value in the column. So in this case, we're going to look at the home column. We're going to find if the next game will be played home or away, and we're going to put that in the current row. And we'll do the same thing for a few other columns. So we're going to do it for the team opponent. So this is just the opponent that the team is going to play next, and then the date they're going to play. All right, So you want to be really careful not to do this for information you won't know in advance, right? So for games that will be played in the future that haven't been played yet, I know if the game's going to be home or away. I know who the opponent is. I know the date of the game. What I don't know is how many field goals each team scored, what their field goal percentage was, etc. So I can't use that information, but I can use this information. So let me go ahead and run this. All right. Did I miss a... I got a few warnings. That could be because I missed a copy earlier. All right, let me just check my data frame. All right, so it looks like my columns have been added properly. This warning can sometimes result, this setting with copy warning can happen if basically you've taken too many slices of a data frame and then you try to assign to it. Sometimes it will actually result in things failing, sometimes it will not. In this case, things seem to have worked okay. But what I will do is just say data frame equals dataframe.copy, just to make sure that the data frame is no longer pointing at a slice of itself. All right, so we now have these columns. These indicate the next opponent the team is going to play, the date they're going to play, and whether the team will be at home or away in their next game. All right, so the next thing we're going to do is actually pull in stats about the opponent. So we have information about how our team has done in the last 10 games. We're going to pull in the same information about the opponent team. So here, the opponent is the Boston Celtics. So we're going to pull in information about their previous 10 games. So to do that, we have to use the data frame merge command. And if you've used SQL, merge tables in SQL, this works a lot like that. This is actually going to do an inner join. And the columns we're going to merge on the opponent side. So the left side, the data frame, is going to be the team we're trying to predict. The right side is going to be their next opponent. And we're going to pull in just a few columns. So we're pulling in those rolling columns. We're also going to pull in information about the next game. So we can merge based on that. All right. And then we're going to say left on. So this is the team that we're trying to predict. We want to merge based on the team column and the date next column. And then right on, the next opponent, we want to merge on the team op next column and the date next column. All right, let me actually space this out so it's a little easier to see. All right, merges can be a little complicated, but basically what we're saying is, hey, we have a team that we're trying to predict data for. We're going to find their next opponent and merge that opponent's information together with our team's information. All right. And it's important to have the date next column and not just merge on the team name, because we want to merge based on their next game, because we want the previous 10 games for the opponent team. So let's take a look at this full data frame now. We can see we have a bunch of these columns that end in _y. So _y are going to be the columns from the opponent team data frame. And then we have a bunch of other columns, and these are the columns from the original team. Some of the columns, you can't see them now, have an _x, and _x is from the original team also. In cases when two columns are named the same, the left side of the merge will get the _x, the right side of the merge will get the _y. So that's why these were automatically renamed for us. Okay, let's take a look at just a few columns of this full data frame, so it's maybe a little bit easier to understand what's happening. I know merges can be a little complicated. So we're going to take a look at the team X, which is the team that we're trying to predict, and their opponent. We're also going to take a look at the team Y, which is the opponent team, and the team op next Y, and the date next. So this will just help us understand how the merge worked. Okay, so we can see this first row is the Sacramento Kings. Their next opponent is going to be the Toronto Raptors, and the date they're going to play is 2015, November 15th. And then you can see on the right side of the merge, we pulled in information for the Toronto Raptors, whose next opponent is the Sacramento Kings on this date. And then the second row is the other side of the game. It's Toronto playing Sacramento, and here is Sacramento playing Toronto. So it looks like the merge worked properly. We have the correct number of rows, and it looks like we can go ahead and continue. So a few rows have been removed, and let's talk a little bit about those rows before we move on. So this was the data frame that I showed you before. And you can see if you look at the very bottom of the data frame, there's a few games where home next, team opponent next, and date next are none or are missing. And the reason for that is these are the last games the team played in the season. So we don't actually have data about if they're at home or not in their next game until the next season starts or who their opponent is. So if you filled this in, you could actually use this to predict future games, which I'll tell you a little bit about at the very end. But when we did the merge, it couldn't find anything to merge these rows with because we had no values in these columns. So it just removed these rows, which is why the row count went down from 15,882 to 15,774. All right. The next thing we're going to do is we're going to run through our sequential feature selector again in order to find the 30 predictors from our new set. So we now have 423 columns, and we're going to see which of those columns are actually best for our model. We'll first create a set of columns that we don't want to pass into our model. And these are going to be all of the columns that have the object data type. So let me actually pull this out and show you which columns have the object data type. So these are all team codes or dates or just columns that we can't actually pass into a machine learning model. We can only pass numeric columns into machine learning. So this is going to give us all of those columns. And then we're going to add it to our old set of removed columns, which also includes columns like the target, which we don't want to pass into our machine learning model when we're training it, and columns like that. So we can take a look at our full list of removed columns. And these are columns that we don't want to pass into our machine learning model, either because they won't work or because they would invalidate our whole exercise, right? If you're trying to predict the target and you feed your model the target, you're going to get results that look great, but don't work in the real world. Because in the real world, you don't know what you're trying to predict before you try to predict it. All right. So we're going to use that removed columns list to just create a list of selected columns. This is exactly what we did before. So basically what we're saying is we're taking all of the columns from the full data frame, except the ones that are in this removed columns list. And that's what that tilde operator does. This is a negation. So we're basically saying, is this column in removed columns? If it's not, then select it into our selected columns list. And then we'll go ahead and fit our sequential feature selector. So that's sfs.fit full selected columns. So these are the predictors that we're passing in. And then we're trying to predict our target. And the sequential feature selector is going to spit out the 30 best features that it thinks will give us the most value for predicting our target. So let's go ahead and run that. It may take a little while for the feature selector to run, but once it's done, we can do something similar to what we did before, just to get these selected columns out of the feature selector. All right, so what this does is it just basically returns a Boolean that indicates whether that feature was selected or not, and then we index our selected columns list by that index. So then we end up with our predictors. So there's a few from the original side. So the team that's actually we're trying to predict the game for. And there's a few from the opponent side. Then we can actually generate our predictions. So we'll pass in our full data frame, our regression model, and our predictors. This is the great part about writing a function. You can just reuse the function instead of writing all of the code again. And then we'll just define our accuracy score. And this is, again, really similar to what we wrote before. And it turns out our new accuracy score is almost 63%, which is a great improvement and a big improvement on the baseline as well. Our baseline was 57%. So this is great. All right. I hope you enjoyed this walkthrough, and I'm going to talk a little bit about two things you can do next. One, continuing to improve the accuracy, and two, how to use this to predict future games. So to improve the accuracy, there's a lot of things you can do. So first, we used a ridge regression model. You can try using a more powerful model to see if that will actually help. So some examples might be XGBoost or random forest classifier. That's where we defined our ridge regression model. Another thing you can do is try out different numbers of features that you're selecting for the model. You could also try backward feature selection to see if that helps. That usually does result in a better set of features. You can also try different ratios. So we looked at the last 10 games when we were computing our rolling averages. You could look at maybe the last 5 games or 20 games, and you could look at the ratios between those, right? You could say, okay, did the team perform differently in the last 5 games than in the last 10 games? Maybe they're on a hot streak recently. So you could try that. I think those are probably the best ways that you can continue to improve accuracy with this model. And then if you want to predict future rows, it all comes back to, let me try to find the part where we were doing that. It all comes back to these missing values. So what you need to do is, one, in the last video, I showed you how to web scrape to actually get the box scores and standings. So you need to actually modify that code. Actually, you don't need to modify the code. You just need to rerun that code to get the most up-to-date box scores. You may need to delete the most recent old standings file for the current season if you're running it over and over, because it does cache the standing files. Then that'll give you up-to-date scores. Then you need to rerun this, and once you get here, you need to manually fill in, or programmatically, if you want to write some code to do it, the next home next. So if the team will be home or away next, who their opponent is going to be, and the date they're going to play. So you need to fill that in both for the team and their opponent. Then you can rerun this to actually merge, and it should actually merge and include those rows after the merge. And then what you'll need to do is just rerun these predictions, and you'll look at any rows where the target is 2, because you'll remember we replaced the target value with 2 when the game was going to be in the future. And then you can find the predictions based on that. So you can use this to predict future games. If there's enough interest, I may record a video on how to do it, but those are the steps of how you can modify this to predict future games. All right, I hope you enjoyed this walkthrough. And if you did enjoy this, please check out Dataquest courses. We have interactive lessons on all aspects of data science and machine learning. And we also have tons of projects that walk you through step by step, just like this, how you can build real world portfolio projects. All right, have a great rest of your day.